Okay, hi, good afternoon everyone. So today we will continue our group theory. Okay, up to what we have done, after that we will continue. So suppose I have, we will find out the point group. So yesterday I gave some questions. Okay, I gave some questions also yesterday. So this is what? This is your eclipsed ethane. Okay, this one is what? This one is your eclipsed ethane. So if you have this kind of eclipsed ethane, you can think like this. Suppose you are visualizing this molecule from this side. Okay, you are visualizing this molecule from this side. So what you can see, basically you can see like this. Okay, you can see like this. So suppose this is your front carbon and this is your back carbon. Okay, front carbon, back carbon. So in front carbon, what you have? In front carbon you have 3 hydrogen. If I rotate by 120 degree, they will exchange their positions and you will get your equivalent structure. So that means here also the principal axis of symmetry, that will be C3. You have to pass along this. Okay, C3. See, if you have, suppose this is your BH3 molecule. Okay, you have done BH3 things, right? BH3. So same thing na. Here also in the center you have carbon and you have 3 hydrogen. So in BH3, what is the principal axis? C3. Here also it is your C3. And you will, when you are visualizing the molecule from the front side, you will see like this. Okay, you will see like this. Okay, so you have one C3 axis, which is your principal axis of symmetry. Now apart from that, you have to check C2 axis is present or not. Okay, C2 axis is present or not. So suppose I am keeping one axis. Okay, this is your one C2 axis I am keeping here, and then I am rotating the molecule. Okay, or you can keep the C2 axis here also in the middle of this bond. Okay, if you keep the C2 axis here in the middle of the bond and if you are rotating it by 180 degree, okay, that time what you will get? You will get C2 axis. So that is what? That is your 3 C2 axis. If you get one C2 axis, you will be able to get 3 C2 axis. Okay, so you are getting one C2 axis through this hydrogen atom, one C2 axis you will get through this hydrogen atom, and the other C2 axis you will get through this hydrogen atom. Okay, so these are the 3 C2 axis you have. Now next you have sigma V. So now tell me, sigma V is present or not? This is also easy. Sigma V is present. You can pass one plane through this hydrogen. So that means this plane is actually cutting this hydrogen atom, this front carbon hydrogen atom, as well as this back carbon hydrogen atom. Okay, so that time what is happening? This hydrogen is becoming mirror image of this hydrogen, as well as this hydrogen atom is becoming mirror image of this hydrogen atom. So if I pass a plane through this hydrogen atom, I am getting one plane of symmetry. Similarly, if I pass one plane from here, okay, one plane from here, so there also I will get another plane of symmetry, and another plane you have to pass from here, okay, through this hydrogen, like this. If you pass like that, so that means you are getting 3 sigma V. Okay, sigma V. And now the next thing is your sigma H. So now see, sigma H is present or not? Okay, sigma H is present or not? So if you pass a plane here, if you pass a plane in between these two, in between this axis, if you pass a plane, so that is what? That is perpendicular to your principal axis, perpendicular to your C3 axis, and that is what? That is your sigma H. So you have one C3 axis, 3 C2 axis, 3 sigma B, and 1 sigma H. All together they are becoming what? They are becoming your D3H point group. Okay, so this is your eclipsed ethane, Okay, this is your eclipsed ethane, and you are getting what? You are getting D3H point group for this eclipsed ethane. Okay, fine. Now next we have staggered ethane. Okay, so suppose this is H1, H2, H3. Okay, and this is your H4, H5, H6. Okay, now I am keeping one C3 axis here. Okay, this is your C3 axis, and I am rotating the molecule by 120 degree in the clockwise direction. Okay, suppose I am rotating the whole molecule in clockwise direction by 120 degrees. So that time what will happen? That time they will interchange their position. So H1 will come to here, H2 will go to here, H3 will go to here, and the back carbon also H5 will come to here. Okay, H6 will go to here, and H4 will come to here. So if you rotate it by 120 degree, you will get this thing. Okay, this is what? This is your C3 axis, right? Now similarly you can see, you can place one C2 axis through this. Okay, through this hydrogen atom you can also place, and through this hydrogen you can place one C2 axis. So you have C3 axis, you have 3 C2 axis, and through this C2 axis you can consider one plane also. Suppose I am considering one plane through this. Okay, through this. So what will happen? See, if I pass a plane, this plane I am passing, so what will happen? This H2 and H3, they are becoming mirror image to each other, as well as this H5 and H4, they are also becoming mirror image to each other. So this is one plane of symmetry. If you are able to find out one sigma v, so ultimately you will have 3 sigma v. And how they are present? So along this hydrogen, this H2, yeah, H2 and H4, H2 and H4. Okay, suppose I am removing this one. If you are not getting, so I am removing it, then it will be easy to understand. Suppose I am passing a plane through this H2 and H4, H2 and H4. So what is happening? H2 and H4. So that time this H1 is becoming mirror image of your H3. Okay, and this H5 is becoming mirror image of your H6. So this is another sigma plane, sigma b plane. Okay, and sigma h is present or not here? Sigma h is present or not here? So here if you see, what you can see, if I pass a plane in the middle, suppose I am passing a plane here in the middle, so that time what? This side you have H1, but see in the opposite side you have nothing. Here you have nothing. Okay, similarly this side you have H6, but in the opposite side here in the middle you have nothing. So that means sigma H is not present here. So you have one C3 axis, 3 C2 axis, and 3 sigma V. Okay, that will lead to what? That will lead to your D3D point group. D3D point group. So when it is your staggered ethane, okay, when it is your staggered ethane, okay, staggered ethane, that time you will get D3D point group. If you have eclipsed ethane, that time you will get D3H point group. Fine, I hope it's clear. Okay, next suppose you have B2H6. B2H6. Okay, so how to write down this B2H6? So boron, okay, hydrogen, boron, here also you have hydrogen. Okay, now above the plane you have hydrogen. Okay, below the plane also you have hydrogen. Below the plane also you have hydrogen. above the plane you have hydrogen. Okay. Yeah, so this is your B2H6 unit. Okay, B2H6 unit. So now tell me, so what will be the principal axis of symmetry? Principal axis of symmetry. So if I pass an axis through here, okay, if I pass an axis through here, so that is what? That is your C2 axis. Along this axis, if you rotate by 180 degrees, these hydrogens will change their positions, right? And you will get your equivalent structure. So this is one C2 axis. Now see, if I, this is another C2 axis. If I rotate the molecule again 180 degree through this C2 axis, that time also you will get your equivalent structure. Okay, so suppose this is your x axis and this is your along z. Okay, this is your along x axis and this is your along z axis, another left, that is along your y axis. So if you pass one C2 axis through this y axis, okay, so that means the molecule will rotate like this. Okay, the molecule will rotate like this below the plane hydrogen, they will come into the above the plane, above the plane hydrogen, they will go to your below the plane if you rotate through this y axis. Okay, so basically you have here what, initially we are getting one C2 axis, and from this one C2 axis we are getting also two C2 axis. Okay, initially we are getting one C2 axis, from this one C2 axis we are also getting two C2 axis. Now the next thing comes your sigma v. So how to get sigma v, how to check sigma v? Check sigma v, sigma h, what you are getting or not. Okay, sigma v and sigma h. So if I pass a plane through this, if I pass a plane through this, okay, suppose I am passing in the middle of the molecule, that time what happens? This hydrogen is a mirror image of this hydrogen, this hydrogen is also mirror image of this hydrogen. So this is one sigma v. If you have C2 and you are getting one sigma v, so ultimately you will get two sigma v, right? The n number of sigma v you will get. Another plane you have to pass like this, another plane you have to pass like this. So these are the two sigma v's you have. Okay, these are the two sigma v's you have. Okay, now the question is, sigma h is present here or not? Sorry, I think this one will be a sigma h, right? Oh sorry, yeah, this is one sigma v, another sigma v will be like this, another sigma v will be like this will contain your this hydrogens, huh? This above the plane you have hydrogen, below the plane you have also hydrogen. So if I pass the plane through this, if I pass the plane through this, above the plane hydrogen and below the plane hydrogen, that time also it is dividing by two equal halves. See, here in the top side you have one hydrogen and bottom side you have hydrogen. Now they are becoming mirror image to each other. Okay, if you pass the plane through this, so that means what, it is also cutting the molecule in the half. Okay, so this top side hydrogen and bottom side hydrogen, they are becoming mirror image to each other. Another plane you can pass through the middle of this boron. Okay, so it is cutting this boron, so that time boron, hydrogen, it is cutting all the things. Okay, that time this above the plane hydrogen is becoming mirror image to your below the plane hydrogen. So these are the two sigma v's. And if you pass a plane here, if you keep a plane here or pass a plane here, that time it is also becoming mirror image to this part. Suppose this left hand part you have BH2, right hand part you have BH2, so they are becoming mirror image to each other. But this plane is basically perpendicular along your C2 axis. Okay, this plane is perpendicular to your C2 axis, so that will be your sigma h. So what you have one C2 axis, two C2 axis, two sigma b and sigma h. So that will lead to what? That will lead to D2H point group. Okay, that will lead to D2H point group. Fine. D2H point group. Okay, now next suppose I have another molecule H3BO3. So H3BO3. So first of all try to draw H3BO3. So H3BO3 will look like this: boron, oxygen, hydrogen. Here you have two lone pair. Okay. Here also you will get oxygen, hydrogen. And here also I will get oxygen, hydrogen. Okay, now which one will be here principal axis of symmetry? Okay, so think it. First of all, if you see recording class also, that time also you have to think. Okay, so think and then guess what is the principal axis of symmetry here. So what could be the elements present here and what could be the point group for this H3BO3 molecule? Okay, think for 1 minute, then I will do. Fine, so here what will be your principal axis of symmetry? So principal axis of symmetry will be again your C3 axis. Okay, I am showing like this, but it is not like that. Think it like this, huh? Actually it is difficult to show, but yeah, think that one axis is coming from this side. Okay, from top. Okay, the axis should be like this, top to bottom. Okay, this is your C3 axis. So suppose this molecule is present in your plane of your notebook and you are keeping one pen now. Okay, you are keeping one pen stand on your plane of notebook. So that is like your C3 axis. So along this C3 axis, if you rotate by 120-degree, this OH will shift to here, this OH will shift to here, this OH will go to here. Okay, they are just interchanging their positions. So C3 axis is present. Fine, C3 axis is present. Now apart from C3, anything is present? C2, those things are present or not? Suppose I am considering one C2 axis like this. I am considering one C2 axis along this. Then I am rotating the molecule by 180-degree. So what you will get? What you will get if I rotate by 180-degree through this axis? That time what you will get? That time see. First of all, this oxygen is OH is changing its position like this. Okay. Now secondly, this oxygen will go there. So it will be like this. Okay, and this oxygen is coming to here, so it will be like this. So you can see the overall structure is changing. This is not your equivalent structure. You can guess by this only. If you rotate by 180-degree, this hydrogen will come to this side, right, like this. So this is not your equivalent structure. So this H3BO3 in this molecule, basically C2 axis is not present. C2 axis is not present here. Okay, C2 axis is not present here. Okay, so if your C2 axis is not present, so now check about the plane. Also you can see sigma v cannot be present here, because if you pass a plane like this, suppose I am passing a plane through this, so that time this side you have hydrogen but this side you have nothing, so that means sigma v cannot be present here. Okay, similarly suppose you are passing the plane through this, so that time you are getting OH, so this side it should be like this, oxygen hydrogen this side na, hydrogen is here, so that means hydrogen is need this side, then only they will be mirror image to each other, right? So here you can see you are not getting mirror image. Okay, so basically sigma v is also not present. But if you take the molecular plane, if you take the molecular plane, okay, molecular plane, that time what you will have, you will have on C3 axis and sigma h, right? So what are the elements we have? C3 and sigma h. That will lead to what? That will lead to C3H point group. Okay, so that will lead to C3H point group. Clear? Fine. Next, check for this molecule H3PO4. Okay, first of all try by your, okay, try by yourself, then tell me H3PO4 you are getting anything or not. So in H3PO4, the molecule is basically looks like this: phosphorus, double bond O. Okay, now you have 3 OH like this. So now I am, see this 3 OH na, they are in the plane. Suppose this 3 OH they are in the plane of your paper, but this double bond O, this is actually present on the top your paper. So that means above the plane from your notebook. This double bond O is basically present above the plane of your notebook, and these 3 OH these are present on the plane of your notebook. Now if you rotate it, if you rotate it by 120 degree, by your C3 axis, if you rotate this molecule by your C3 axis, okay, through C3 axis by 120 degree, you will get your symmetrical uh, equivalent structure. So C3 is the principal axis here. And now if you talk about your C2 axis, so C2 axis is basically not present, because see if you pass here, okay, so this OH will go to that side. Now that is not your equivalent structure, right? This suppose you are passing one C2 axis from here, so this OH will go to that side. That is not your equivalent structures. C2 axis is not present here. Apart from C2, if I see sigma v, so sigma v also you can say. So if I pass a plane through this, okay, if I pass a plane through this oxygen, so that time see this side you have OH, that side you have nothing, so that means sigma v is not present. You can pass one sigma v through this axis also. Okay, you can think like this, that I will pass through this oxygen and through this oxygen, but that time also you can see this side you have hydrogen but this side you have nothing. Okay, if you pass a plane like this na, that time also you can see For this OH, this side you have hydrogen, but this side you have nothing. So that means what? Sigma V is also not present. And here, if you take the trigonal plane like this, okay, suppose you are taking this trigonal plane, okay, so suppose you are thinking that okay, I will pass through the plane of the molecule. So this is basically your molecular plane. But see, above the plane you have double bond O, and below the plane you have nothing, right? Above the plane you have this double bond O, but below the plane you have nothing. So that means sigma H is also not present here. Okay, sigma H is also not present here. So only you have C3 axis, and that is why the point group of this molecule will be C3. Okay, point group of this molecule will be C3. Okay, clear? If it is, if you have any doubt, then tell me in the next class. Okay, but yeah, I hope it is clear. Now suppose you have linear molecule. Suppose you have linear molecules. So these linear molecules are basically two types. These linear molecules are two types. So one is your symmetrical, one is your symmetrical type, and another one will be your unsymmetrical. Okay, another one will be your unsymmetrical. So suppose you have symmetrical molecules, suppose like this oxygen, double bond oxygen. Okay, so we have done this kind of thing. Yesterday also you have done acetylene molecule. Okay, so that time you will get this point group D infinitive H. Okay, this is the point group for your symmetrical linear molecule. And for unsymmetrical molecule, suppose you have this kind of thing HCl, so that time you will get C infinitive V, that point group. Okay, so these are the two point groups we can get. One is your symmetrical point group, another one is your unsymmetrical. Okay, another one is your unsymmetrical. If you have unsymmetrical, that time you will get this C infinitive V point group. If you have symmetrical molecule, you will get D infinitive H point group. Okay, because in unsymmetrical that what in unsymmetrical the sigma H is not present. Okay, sigma H is not present in your unsymmetrical molecule. Try to find out in this molecule what is the point group you are getting. For this molecule, what is the point group you are getting? So you can see that you can pass one C2 axis from this axis. Okay, you can pass one C2 axis from here. You can pass one C2 axis from here. Okay, and you can pass one C2 axis from this Y axis also. So basically you will get one C2 axis and two C2 axis from this. Okay, now apart from this you can have sigma V also. So sigma V will be like this. One sigma V is like this. Okay, so this is the plane of symmetry we have, which actually cuts the molecules, and another sigma V will be like that. Okay, so we will have two sigma V. Now the question comes for your sigma H. Sigma H is present here or not? Sigma H is present or not? So if you contain, this is your C2 axis, right? This is your C2 axis. C2 axis. Okay, now if I contain this molecular plane, Okay, if I think about this molecular plane, so this molecular plane is basically what? This is actually perpendicular to your C2 axis. This molecular plane is actually perpendicular to your C2 axis, and that is what? That is your sigma h. Okay, so you have one C2 axis, then two C2 axis, two sigma v and sigma h. So that leads to what? That leads to D2H point group. Okay, that leads to which point group? D2H point group. Fine. Suppose you have this. Okay, so try to find out the point group for this molecule. Try to find out the point group for this molecule. So what will be the principal axis of symmetry here? So principal axis of symmetry is your C2 axis. Okay, C2 axis is the principal axis of symmetry. Now think about sigma v. So one sigma v will be like this. Okay, like this is your one sigma v. If you pass the plane through this, okay, so that is one sigma v, and another sigma v will be like this molecular plane. So these are the two sigma v you have. So you have one C2 axis and two sigma v. Sigma h cannot be present because if you pass a perpendicular plane, see Cl these are not mirror image. Cl hydrogen are not on mirror image. Apart from that, you have here double bond, but below side you have nothing. So C2 and 2 sigma v, that will lead to what? That will lead to C2v point group. Okay, that will lead to C2v point group. Okay, suppose you have pyridine. Suppose you have pyridine. This. Find out the point group for pyridine. So here also you will have one C2 axis. Okay, this is your C2 axis, and apart from that you can sigma v. Okay, you cannot place C2 from here. If you place, that time the nitrogen will go to the upside, so that is not your equivalent structure, right? So only one C2 axis is present here. Apart from that, anything is there. Sigma v. So one is along this plane. Okay, this is one. Another one will be like this, perpendicular. Okay, both the planes, this planes actually cuts this nitrogen and this carbon. Okay, this plane, this perpendicular plane, this actually cuts your this carbon atom and nitrogen atom. So this left hand is becoming mirror image of the right hand, and another plane is like this through the molecular plane. So what you have one C2 axis and two sigma v. That will lead to what? C2v point group. That will lead to C2v point group. Okay, now what about this? What about this? So here you can place one C2 axis through this carbon atom, okay. So that means through the middle of this whole molecule, okay, through the middle of this whole molecule. So this is your one C2 axis. So one C2 axis I am keeping through the middle of this whole molecule, and if you rotate by 180 degrees then you will get equivalent structure. So through this carbon atom only, through this middle of this whole molecule, you will get only one C2 axis. Apart from that you will get nothing. You cannot place the C2 axis here or here, anywhere, okay, only through this carbon atom. So this is one C2 axis. Now what about your sigma v? Sigma v is present. So yes, sigma v is present. So the plane will be like this. This is cutting this carbon atom, middle of this edge and middle of this edge. So that will be one plane. Okay, one plane will pass like that. Okay, it cuts this carbon atom, middle of this edge and middle of this edge. So this is your one sigma v, okay, which contains your principal axis. Another sigma v will be like this. So this actually cuts this carbon atom, this carbon atom and this carbon atom. So that means this bridge, okay, this whole bridge, okay, the plane I am passing through this bridge. If you passing a plane through this bridge, so that means this part and this part, they are becoming now mirror image to each other. So what we have, we have C2 axis and 2 sigma v. So that will lead to what? That will lead to C2v point group, okay, that will lead to C2v point group. Okay, now next, suppose you have this, okay. So if you get this kind of molecule na, see in the front side what you have, front carbon, what you have, front carbon you have this na, similar to your BH3 type of molecule, okay, similar to your BH3 type of molecule. So you can pass a C3 axis from here. Similarly here also you can pass one C3 axis from here. So if you pass one C3 axis, this part will go there, this part will go there and this part will go there. They will interchange their position. So this is your 1C3, okay, 1C3 you are getting. Now C2 is present or not? C2, what about C2? C2 is also present, okay, C2 is also present. Suppose I am showing you, suppose you are placing one C2 in the middle of this, okay, middle of this I am placing one C2, and if you rotate it by 180 degree through this C2 axis, that time you will get equivalent structure. That will be one C2. Another C2 you have to place like this through the middle of this, okay, of this plane and through the middle of this plane. So these are the three C2s you have, okay. So you have C3 as your principal axis of symmetry, you will have 3 C2 as your subsidiary axis, and apart from that what you are getting, sigma v is also present, okay. You can see the sigma v. Where is sigma v present? Sigma v is also present here. Can you explain where you will get the sigma v? Just a minute. Yeah, so now the question is where you will get the sigma v. Okay, sigma v, I am asking about sigma v. So if you see, you can pass one plane through this. If I pass one plane through this, so that time what happens? This side and this side, they are becoming mirror image to each other. You can pass another plane through this. Okay, if you pass this plane, that time also this and this, they are becoming mirror image to each other. Another you can pass through this. Okay, if you pass through this, so this and this, they will be mirror image to each other. So basically you will have 3 sigma v. Now next question is about your sigma h. Sigma h is present or not? Sigma h is present or not? Sigma h is present or not? So this is your c3 axis. Okay, this is your c3 axis. Now check, any perpendicular plane exists? Yes, it is existing. So the plane will cut middle of this bond, middle of this bond, and middle of this bond. So if I pass a plane like this, if I pass a plane like this, okay, that will be perpendicular to your c3 axis. Okay, and what you are getting? You are getting sigma h plane. So I have c3 axis, 3 c2 axis, 3 sigma v, and sigma h. That will lead to what? That will lead to d3h point group. Okay, that will lead to d3h point group. Okay, now suppose you have this nitrogen. Okay, nitrogen, this. So 1 2 3. So here also you can place one c2 axis here. Okay, if I place one c2 axis here, okay, so you can place this c2 axis. Sigma v is also present. You can place one plane from here through the middle of this nitrogen and nitrogen, and another plane will be your what? Another plane is your molecular plane. So again you have c2 axis and 2 sigma v. So you will have c2v point group for this molecule. Okay, now suppose you have this atom, this molecule. So this is cyclobutadiene. Okay, cyclobutadiene. In the middle you have nickel metal, and here also you have one cyclobutadiene. So basically the nickel is sandwiched between the two cyclobutadiene units. So what you will have? So see, you can pass one axis from here. So this is a cyclobutane ring. So that means the axis will be what? C4 axis. If you rotate by 90 degree, 1 2 3 4, what will happen? The 1 will go to here, 2 will come to here, 3 will go to here, 4 will come to here. So basically if you rotate by 90 degree, you will get equivalent structure. You will get equivalent structure. So C4 axis is present here. Now what about C2? C2 is also present. See, suppose if I place one C2 axis here, and now I am rotating the molecule by 180 degree. So these two cyclobutadiene, they will change their position. This will go to here, this will come to here, right? And if you are able to find out one C2, so that means ultimately you will have 4 C2. Okay, if you are able to find one C2, ultimately you will have 4 C2. Okay, so this is your one C2. Okay, now you can place one C2 from this corner. Okay, you can place one C2 from this corner, and another you can place like this along y-axis. Okay, that will also work out. So ultimately you will have 4 C2, 4 sigma v you will get. Along this C2 you will get sigma v also. Okay, along this C2 you will get sigma v. So you will get one plane through this corner and through this corner. You will get two planes. One plane you will get through the middle of that and through the middle of that. So these are the 4 sigma v you will have. Okay, these are the 4 sigma v you will have. Okay. Okay, what I am trying to say here, that one plane you are passing through the middle of this. Okay, through the middle of this is your one plane. Okay, another plane you are passing through the middle of this. Okay, through the middle of this. Another plane you are passing through this corner. Another plane you are passing through this corner. So these are the 4 sigma v you will have. And if you pass a plane through this, through the middle, okay, through the middle, so that is what, that is basically vertical to your C4 axis. This middle plane is basically this plane. Okay, I am drawing with different color. So this plane, this plane is what, this plane is perpendicular to your C4 axis. Okay, so that means what, this is your sigma h. So you have C4 axis, 4C2, 4 sigma v and sigma h. So that is what, that is your D4H point group. Okay, that is what, that is your D4H point group. Okay, so this is your staggered conformation. Sorry, this is your eclipsed conformation. This is your eclipsed conformation, and another one will be staggered. So staggered will look like what? So staggered will be little bit change, huh? So this cyclobutadiene will be like this. So this is your staggered. Okay, so here also no need to worry. If you pass C4 axis from here, okay, and if you rotate by 90 degree, if you rotate by 90 degree, that time also you will get your equivalent structure. Suppose this is your 1 2 3 4 and this is your 5 6 7 8. So they will just interchange their position if you rotate by 90 degree. So C4 axis is present here. Now the question is, C2 is present or not? C2 is present or not? C2 is present or not? Suppose you can do it. Suppose this is your one matches box and this is your one matches box. Okay, they are staggered to each other. Okay, now tell me, C2 axis is present or not? So here C2 axis is present. Okay, C2 axis is present. Now the question is how. So you have to actually rotate around this C2 axis. Okay, so that actually needs the help of model, I believe that. But yeah, you can think also that suppose you can take one matches box like this and below you can keep one matches box like this. Now if you rotate along this CY axis, along the Y axis, and you are rotating by 180 degrees, so that time this ring will go like this and this ring will come to here. Okay, so you will have C2, and if you are able to find out 1 C2, so that means ultimately you will have 4 C2. Okay, sigma v is also present, so you will get 4 sigma v, but sigma h is not present. Why? Because if you pass a plane here perpendicular to this C4 axis, see, this ring is not the mirror image of this ring, right? The upper one is not the mirror image of this lower one ring, right? So you have C4, 4C2 and 4 sigma v. That will lead to what? That will lead to D4D point group. Okay, that will lead to D4D point group. Okay, fine. Okay, suppose you have this toluene molecule. Okay, suppose you have toluene. Toluene. Tell me the point group of this toluene molecule. So you will have one C2 axis and 2 sigma V, which will lead to what? C2V point group. Okay, suppose you have this molecule. Above the plane you have bromine, below the plane you have chlorine, and you have 2 hydrogen. So that will be what? So you can pass a plane through this bromine and chlorine. Okay, if you pass a plane through this bromine and chlorine, that time this hydrogen is the mirror image of this hydrogen, and that is what? That is your CS point group. Okay, apart from that you will get nothing. Okay, CS point group. Suppose you have, okay, this toluene thing na, toluene thing, actually if you do like this, okay, so that will be wrong basically. Okay, that will be wrong basically. Why? Because this CH3 hybridization is sp3. Okay, CH3 hybridization is what? sp3. So keep in mind, this is your benzene ring, and suppose the methane you have to show like this methyl group you have to show like this. Okay, so this is similar to what? Similar to your ammonia kind of system. This is similar to your ammonia kind of system. Okay, so here also the point group is what? C3b. Here also the point group is what? C3b. You can pass one C3 axis. Okay, that is your C3 axis, and you will have 3 sigma V along 3 hydrogen. Okay, that's it. So this is your C3b point group. Fine. So yeah, that's it. This was examples we have. I hope it is clear now. Okay, if you are getting any difficulty or any doubt you have regarding this finding of this terms in yeah, these term symbols, then tell me. Okay, but yeah, we are now done with this. Okay, this point group is very important basically in NEET exam, also in GATE exam. They ask questions from here. Okay, from this point group. So you must need to know how to find out the point group, because if you are not able to find out the point group, you will not able to do the advanced application of group theory. Okay, so first thing you have to know how to find out the point group. Okay, if you are getting the point group, then it is pretty much fine for you. Okay, now you will be able to understand all the applications part what we are doing. Fine. Okay, okay, so that's it. Now next we will discuss about symmetry operation. So write down symmetry operations. Okay, symmetry operations. So first of all we will do multiplication. Okay, first of all we will do what? Multiplication. So multiplication means what? Multiplication means this C2Z into what? Sigma YZ. C2Z into sigma YZ. Suppose I am doing this C2Z into sigma YZ. So see, first of all, if I draw a molecule, suppose water. Water is there, H1, this is your H2. So C2Z means what? Z means C2 axis you are passing through Z axis. So I told you in the beginning class that this is your X axis, this is your Z axis, okay, and this one will be your Y axis. Okay, so C2Z means the C2 axis will be, or C2 axis, yeah, it is through your Z axis like this. This is your C2Z. Okay, this is your C2Z. Okay, so suppose I am rotating the molecule through this C2 axis. So what you will get after applying C2Z? What you will get? What you will get? So basically you will get like this: oxygen, H2 will come here, H1 will go here. Okay, like this. Now see how to do this kind of thing. So I'm not talking about now C2. So if they have given an exam like that, C2Z cross sigma yz, so now the question is like which I have to apply first, C2Z or sigma yz, that we have to check. Okay, suppose I am writing in mathematics, you have seen that suppose I am doing this y into df of dx. So what you will do, first of all, multiplication with y or derivation with respect to x, what you will do? Definitely derivation, right? Suppose I want to know that, okay, you have some function f, so we have this equation, so what you will operate here, first of all you will do derivation, then you will do multiplication, right? First of all you will do derivation of f, then you will do multiplication with y. So similarly here also, which is present in the right hand side, that you have to operate first. Later one, the left hand side, that will operate later. Okay, so here also same thing, sigma yz you have to operate first. So if I apply here sigma yz, so now tell me, yz plane means which plane? This is your x, this is your y, this is your z, right? Z, x, y, x, y, z. Okay, so yz planes means this plane. Okay, this plane, this is a kind of perpendicular plane. Okay, so yz planes means this plane. Okay, so if you pass this plane through this oxygen atom only, this h1 and h2 are becoming mirror image to each other. Okay, this is your yz plane, and if you pass yz plane, what you will get, in the mirror image, what you will get, h2 will come to here and h1 will come to here, right? If you are passing a plane, so you just draw the mirror image, what you will get in the mirror image, h2 will be in the opposite side, h1 will come to the opposite side, that's it. Now you have to do what, now you have to apply this C2Z. So if you apply here C2Z, so that means what, this is your z axis, so I am rotating now 180 degree through this z axis. So what you will get, this whole molecule will rotate, right? This whole molecule will rotate. So oxygen is here. Okay, h1 is coming to this side, h2 is coming to this side. Clear? Now another thing, if you notice, another change is happening here. This h1 h2 and this in h1 h2, they are equivalent, that is fine. Okay, they are equivalent, there is no doubt. Okay, but one thing is there, suppose you are standing here. Okay, suppose I am asking that something, you are standing here. Okay, suppose I am drawing a particular shape, because I am not that much expert in drawing. So suppose I am standing here. Okay, I am standing here. Now you are taking my mirror image. Okay, so suppose this is my left hand, right hand. Okay, so what you will get, you will get another object same, you are getting my mirror image, right? Now what you are doing next, you are rotating me by 180 degree. So what I will do, I will rotate by 180 degree. Now suppose this is your right this is your right hand, this is your left hand. In the mirror what you will see, left hand, right hand. Fine. Now you are again rotating me, so you will get again right hand, left hand. Fine, both are equivalent. But one thing is happening, what? So suppose this is my front face. Okay, this is my front face. When you are doing this 180 degree rotation na, here C2Z, you are rotating me by 180 degree. Okay, you are rotating me by 180 degree, or suppose I am rotating 180 degree, what you will see, you will see my back face. Clear what I am trying to say? Initially you have right hand, left hand, here also you have right hand, left hand, but what is happening here, you are observing what, front face, but here you are observing back face. So same thing is applicable to this molecule also. Okay, same thing is applicable to the molecule also. Okay, you are first of all you are taking mirror image of that, so you are getting this h2 h1, and if you are rotating by 180 degrees, so that is actually the back face, and back face we will show it like this. Okay, So that represents back face of the molecule. Okay, that represents back face of the molecule. This is the front face and this is the back face. Okay, now can you tell me, is there any other method by which I can get this back face? Directly, suppose I am want to convert this molecule into back face. Is it possible? Possible, right? How can you do it? You can keep a mirror in front of this molecule. If I place a mirror in front of this molecule, that time what? Automatically you will get the back face of the molecule, right? That will be the mirror image. So this plane is what? This plane in front, what I am placing, this plane is what? This plane is what? XZ, na? So this is your sigma XZ. Okay, so what I can conclude? I can conclude that C2Z into what? Sigma of YZ, that will be equal to sigma XZ. Okay, so initially I have here H1 H2 sigma YZ. Okay, if you take mirror image of that, you are getting H2 H1, then you are rotating by 180 degree, you are getting back face of the molecule but symmetrical structure. Now if I place here a mirror in the front of this molecule, a mirror in the front of this molecule, that time it will you can see the back face of the molecule, and that is what? That is your sigma XZ. That is what? That is your sigma XZ. Okay, now basically for all the examples or all the molecules it is not possible to check like that, so we will use some equation here. Okay, that will be easy because exam time, that time you have not that much time that you will be able to see by doing all the things. So first of all, write down that if you suppose sigma. Okay, sigma. So sigma means what? Sigma represents a plane, right? Plane. So I cannot, sigma always represents actually plane. So that means it will involving two axes. Okay, x, y. Suppose I am talking about sigma x, y. So that means you can represent a plane, right? This is your x axis and this is your y axis, right? So I am talking about this plane. But suppose I am talking about only x, I can write down sigma x. This is not possible. Why? Because you have to mention the other axis also. If you are mentioning two axes, that means you are mentioning one plane. Okay, so sigma always represents two axes. Okay, if I am talking about any plane, so I have to specifically mention the two axes. Okay, through what actually I want the plane. So write down sigma xy. So that means what? Two axes included, and this is a masked thing. Okay, two axes included, and this is a very masked thing. Okay, two axes included, and here you will get 1 minus. Okay, here you will get 1 minus. Now suppose I have C2. Okay, C2 axis. So that time write down here, suppose you are mentioning C2, so I can mention through Z axis, through X axis, through Y axis, anything. So here only one axis included. Okay, so for C2 only one axis included, and if you are including only one axis, so that means you will get 2 minus. Okay, you will get 2 minus here. So if you have sigma, so here you are getting xy, here two axes are including, here you will get 1 minus. If you have C2 axis, one axis is including and you will get 2 minus. That is the thing. Okay, that you have to remember, otherwise rest of the thing you can do easily. So Cartesian coordinates you have studied, I think, in your mathematics, Cartesian coordinate. So suppose I am doing how to do sigma xy. So C2 cross or C2 multiplication sigma yz. What you have here? You have here x, y, z. Okay, x, y, z. Now if I operate this sigma yz on this x, y, z, if I operate it, what I will get? So I will get C2z. Write down C2z like that only. Sigma yz you are applying. So see, sigma yz means what? Two axes included, you will get only 1 minus. Okay, now how to check what you will get? So sigma yz you are applying, here you have x y z. So if you have already yz, no need to change anything in your yz. If you have already yz, no need to do change in your yz, only x you can change, and that will be what? That will be your minus x comma y comma z. So if you operate sigma yz on x yz, what you will get? You will get minus x comma y comma z. Clear? Now if you apply c2z on this minus x comma y comma z, so along which axis you are rotating? Z, right? Along which axis you are rotating? Z. So that means in z you cannot change anything. Okay, z will remain same. Z will remain same. Other two axes you have to change with minus sign. Okay, c2z, so that means along z axis you are rotating, so that means z axis no need to do any change, other two you have to change. So if you have minus x, now you are getting minus of minus x. Okay, minus of minus x comma what? Minus y comma what? Z. And this minus of minus x is equal to what? Plus x. So x comma minus y comma z. Okay, so that ultimately you will get. Okay, that ultimately you will get. So c2 cross sigma yz of x y z, you are getting x minus y z. Now apply here. See what we have found here, that c2 into yz is equal to sigma xz, right? So suppose you have sigma xz and you are applying on what? You are applying on xyz, so that will be equal to what? Sigma xz. So xz, so that means xz, so that means x and z they will not change, x and z will not change. In y you have to give a minus symbol, so x comma minus y comma z. Okay, that will be your answer. Okay, like that you have to do the symmetry operations. Okay, okay, now I am doing something. So suppose you have this c2z into what? Sigma of xz of what? X y z. So see, you have xz, so that means x and z no need to change, so write down simply c2z. Okay, xz no need to change, so that means what you will get? X comma minus y comma z. Now what you are applying? c2z, so that means z no need to change, rest of the things you have to change. So x will become now minus x, minus y will become now y, and z is remaining unchanged. Okay, so if you have what? c2z into sigma xz of xyz, what you are getting? Minus x comma y comma z. How can you get directly from xyz? How can you get directly this minus x comma y comma z? How can you get directly? So x is getting minus, so that means you can apply sigma yz on what? X y z. If I am applying sigma yz on x y z, so see, yz is here, yz is also here, so no need to change in yz, only x will change. What you will get? Minus x comma y comma z. So that means basically what? This c2z into sigma xz, that will be equal to what? Sigma xy. Clear? Clear? I hope it's clear. Okay, we will do few more examples, no need to worry. Suppose you have here c2x into sigma yz of what? Sigma yz of x y z. So see what I have? Yz, so that means in yz no need to change, yz no need to change, only the x will change, so it will become what? Minus x comma y comma z. Now here you have x, here also you have x, so no need to change in x, y and z will change. So what you are getting? Minus x, y, x no need to change, y and z will change, so you will get minus y minus z. So from x y z you are getting minus x minus y minus z. So this is actually known as your inversion center, so if you take inversion center you will get directly. So if you are getting like minus x minus y minus z, so that means you are getting what? You are getting here I, inversion center. Okay, inversion center I explained. What is inversion center? If you are starting from this point, you are going to this way. Okay, just a minute. If this is a point, I am getting in this direction, so opposite direction I will have the same thing. Up direction I am getting something, down direction I will also get the same thing. So this is your inversion center. So if x from x y z, if you are getting minus x minus y minus z, so that means this is your this is your I center. Okay, inversion center. So c2x into sigma yz, that will become equal to your inversion center I. Okay, now next, suppose I have what? C2x into sigma xy of what? xyz. These are the Cartesian coordinates you have. So xy, so again no need to change xy, only z we will change. So if we change the z, what I will get? X comma y comma what? Minus z. Now c2x, so that means x no need to change in x, no need to change in x. So what I will get? X is not changing, y will become minus y, minus z will become only z. How can you get directly from x y z? How can you get directly x minus y z? If you apply which plane? Sigma xz plane. Only one minus, so that means you have to apply sigma. If you apply sigma xz on x y z, so through this xz no change, only y will change, so you will get x comma minus y comma z. Fine. Now suppose next you have this sigma yz into sigma xz of what? Of your x y z. So if I apply xz, so that means x and z no change will be there along your x and z. So first of all write down sigma yz. X and z is not changing, so what I will get? X comma minus y comma z. Now yz, so that means no need to change along your yz, just change along x, so you will get minus x. Okay, minus y z, minus x minus y z. How can you get this minus y z from x y z? If you apply which axis? C2z, C2z na. If you apply C2z on your x y z, so along z no need to change, other two you will change, so you will get minus x minus y z. If you have sigma, you will get 1 minus. If you have C2, you will get 2 minus. Clear? Okay, let's do another example. Suppose you have C2x into C2y of what? X, y, z. So C2y, so that means no need to change y. So what I will get? C2x into what? I will get minus x, y, minus z. Now C2x, so no need to change in x, other two we will change. So what I will get? Minus x, minus y and z. Now from this x, y, z, how can I get this minus x minus y and z? If you apply which axis? C2z, right? If you apply here C2z, so again you will get this minus x minus y and what? Z. Fine. Okay, next suppose you have sigma xy into sigma xy of what? X, y, z. So if you have xy, no need to change in xy, z will change. So this sigma xy remains here into what? Z will change. So x comma y comma minus z. Again you have xy and here you have xy. So no need to change in xy, z will change only. So it is becoming now xyz only. So from xyz you are getting xyz. That is what? That is your identical E. Okay. So if you are doing anything sigma xy into sigma xy, so that means what? You are operating for 2 times, na? You are operating for 2 times. So sigma square xy is equal to what? Identical. If you operate the same operator for 2 times, you will get identical. Okay, if you are operating the same operator for 2 times, you will get what? Identical. Clear? Now another thing left, that is your, sometimes they write down like this, S4Z. So S4Z is equal to what? S4Z is equal to like this, C4Z. Okay, so that means you are rotating along Z axis and the plane will be perpendicular of that, so it will be sigma xy. Okay, S4, S3, S2, whatever they are writing. So that means S4 means what? It is actually the multiplication of your rotation and plane. So C4 axis and C axis and sigma plane. Now C4 you will rotate by the same axis what they are giving here in your Z, S axis. Suppose they are giving S4Z. So that means C4Z into the plane will be perpendicular of that XY. Okay. So suppose I am giving this sigma xy into S4Z of what? Your x, y, z. Now this is what? This is your sigma xy. Okay. Into what? S4Z is basically what? S4Z is equal to C4Z into what? Sigma xy of what? X, y, z. So xy is here, xy is also here, z will only change. So here I have sigma xy into what? C4Z. Okay, into what? So you will get x comma y comma minus z. Now see, C4Z, so z is here, so z will not change, other two will change. So keep in mind sigma xy, keep in here, x and y will change, so I will get minus x minus y minus z. Now sigma xy, so this xy will not change, z will only change. So what I will get? Minus x minus y and z. Okay, how can you get directly from here to here? How can you? Sigma xy. Okay, if you apply sigma xy, you will get directly from here. Clear? So yeah, these are the things we have. Okay, nothing left, I guess. C4Z, yeah, you will get same thing. Okay, so these are the things we have. Okay, symmetry operations. Symmetry operations we have this multiplication. Okay, now next day, okay, I am not starting today because this will take time. Group multiplication table we will start. Okay, so now actually from which part they are asking questions, that part we will start now. Okay, because this point group determination and this your symmetry operations, these are the some of these fundamentals you have to know in your group theory, but the main questions they are asking from your group multiplication table. Okay, so that we will start in the next class, so that means next week. Okay, so yeah, that's it for today. Okay, if you have any doubt, any difficulty you are facing, just let me know in the next class, or you can directly message in the WhatsApp group also if you are finding any issue. Okay, okay, fine, thank you all, bye.